In this video we'll be doing reaction stoichiometry, but we'll incorporate what we've learned about volumes of gases. So we'll be calculating either mass to volume of gas or volume of gas to a mass. Like any stoichiometry, we'll go through a process. We'll start by identifying our data. We'll write a balanced equation. Then we'll look at our known or our unknown. In this case, our known could be a volume of a gas, which we might have to convert to a mole, or it could be a mass. Either way, we should be able to find a mole. Then we'll use our balanced chemical equation to find the unknown. And finally, depending on what the question asks, we either find a mass of the unknown or we find a volume of the unknown. So you can see here that we've actually added to our flowchart. So initially our flowchart only had mass known, going to moles known, moles unknown, and mass unknown. Now you can see that if we start with a volume of gas, depending on if it's at STP, we use this formula to calculate the moles. If it's not at STP, we use PV equals nRT to calculate the moles. Whatever we do, we should always be able to find the mole. Now, once we've got our mole, we use our balanced chemical equation in order to find our moles of our unknown. Now, we're either going to find the mass of an unknown or we're going to find a volume of gas of unknown. And once again, if the volume of the gas is at STP, we would use this formula. But if it's not at STP, we would use PV equals nRT. Now let's try an example. So it says calculate the volume of carbon dioxide. So we're going to be finding a volume of carbon dioxide produced at 25 degrees Celsius and 110 kilopascals, and we have 3.75 grams of hydrochloric acid reacting with excess calcium carbonate. So we've identified our data, and now we're going to have to write an equation. So we know that calcium carbonate, which is a solid, reacts with hydrochloric acid to give us a salt, which is calcium chloride, water, and carbon dioxide gas. Now, we need to identify what was the known and what was the unknown. And if you look at this, you can see here that we've got a quantity of hydrochloric acid. So that is our known. And we've been asked to find the volume of carbon dioxide. So that is our unknown. So for this particular question, we're starting here with a mass of a known. So we are going to have to find the moles. And to find the moles, we're going to use number of moles equals mass over formula mass. So remember, our known is our hydrochloric and our unknown is our carbon dioxide. Our task is now to find the number of moles of hydrochloric. And because we've got a mass, we're going to use mass over formula mass. I've told my marker exactly what I am doing. So the mass is 3.75 grams divided by our molecular mass, which is 36.458. And this comes out to be 0.1029 moles. Now, I'm actually going to store that information in my calculator. Okay, so now that we've got our moles known, we need to find our moles unknown. And to do that, we need to use our balanced chemical equation. So remembering, our known is our hydrochloric and our unknown is our carbon dioxide. So the number of moles of carbon dioxide will equal unknown over known times the known, moles of the known. And the moles of the known in this case is hydrochloric. So the unknown, we go to here, look at the coefficient, and you can see the unknown's coefficient is 1. The known's coefficient is 2 times the number of moles of hydrochloric, which is 0.1029 moles, and that comes out to be 0.0514 moles. And I keep that information in my calculator. So now that we've got our moles of unknown, we've been asked to find a volume of the gas. So we are going to either use this formula or this formula. So because our volume of gas is not at STP, I'm going to be using the ideal gas equation, PV equals nRT. So finally, remember, here's our known, here's our unknown. We are up to finding the volume of the gas. So our temperature that we've been given is at 25 degrees Celsius. So the first thing we're going to need to do is convert our temperature into Kelvin. So that is 25 add 273.15. And this comes out to 298.15 Kelvin. Now that we've got our temperature in Kelvin, we can substitute directly into our equation, PV equals nRT. We know the pressure was 110 kilopascals, so 110. We don't know the volume. We know the moles was 0.0514 moles. We go to the gas constant we get off our data sheet, which was 8.314, and the temperature we've already calculated is 298.15. So rearranging this equation, you'll end up with 110 times velocity times the volume is equal to 127.48. So the volume equals 127.48 divided by 110, which equals 1.16 litres. Checking significant figures, you can see that the original quantity was in 1, 2, 3 significant figures, and our final answer is in 1, 2, 3 significant figures. Now I would like you to try one yourself. So go to the OneNote, try the kinetic theory calculations, ideal gas equations, and at the bottom, and there's some worked answers on space.